This is part two of lessons in AI LLMs. Enjoy. A large language model is a type of AI that tries to predict the next word, or more accurately, the next token in a sentence based on what came before it. Now, you might be thinking, is that it? That sounds almost too simple. And you'd be right, in a sense. But as simple as it sounds, it isn't the actual process of how language models make those predictions where the real complexity lies. Imagine this. You're texting a friend who just happens to have a Marvel Comics level ability to absorb everything he reads. I'm talking every book, every website, every Wikipedia article, and every Reddit thread ever written for the sake of it. Let's say your friend's name just happens to be ChatGPT. Today, you might text your friend to write you a story. Tomorrow, you might ask him to help with your homework or answer random questions. And no matter what, he always seems ready to help. That friend is basically a large language model. To give it a formal, less simple sounding definition, large language models are advanced AI systems based on deep learning and transformer architectures, trained on massive data sets to understand, summarize, generate, and predict text and code. Is what powers Google Gemini, Claude, and of course, the famous ChatGPT. Now, I want to focus on one key word, and that is the word large. And boy, does it live up to its name. The word large pertains to the absolutely massive amounts of data that these models are trained on. Some of the biggest language models have been trained on hundreds of billions to over a trillion words. To give you perspective on just how massive this is, if you had to read through all the words these models are trained on for 24 hours a day, with no breaks, no sleep, or interruptions of any sort, it would take you roughly 7,600 years of nonstop reading to get through it all. Even if you started reading when the first pyramids were built, you'd still be at it today. And it's not just the amount of text that's large. The actual models themselves are massive. Inside these models are billions, sometimes trillions of tiny parameters, which are adjustable numbers that control how the model predicts language. And also, I should add that the term large certainly applies to the energy bill as well. So where does all this data come from? It's a place that we all frequent every single day, where trolls, haters, and know-it-alls come together to leave some kind of digital footprint, the internet. The largest portion of data comes from the open web, including all the publicly available texts, blogs, news articles, and forums, such as Reddit. The data also comes from digitized books, Wikipedia, conversational data, and even code repositories like GitHub and Stack Overflow, which is always full of perfectly kind, welcoming, and patient people. Okay, so we know now that large language models are massive. They've read more text than any human could even dream of, and they're complex enough to make your laptop spontaneously combust if you try to run one on it. But how do they actually learn from all that data to sound? Well, human. It all starts with something called tokenization. Let's walk through this with an example of one of the most popular and well-known large language models, GPT, the same language model that powers ChatGPT. When you type something into ChatGPT, that message you send is called a prompt. Think of it like asking the AI a question, giving it an instruction, or starting a conversation. But here's the thing. Large language models don't actually understand words the way we do. Instead, your text has to be converted into a format that the model understands. That's where tokenization comes in. Tokenization is the process of breaking down text into smaller chunks called tokens. These tokens can be full words, parts of words, or even punctuation marks, depending on the language model. For example, the sentence "machine learning is awesome" might get chopped into pieces, like this. Each of those tokens is then translated into numbers, because ultimately, that's the only thing the model understands. Those numbers are not random. Before the model does anything else, each token gets turned into something called an embedding. An embedding is basically a vector, which is a list of numbers that represents the meaning of that token. You can think of embeddings like coordinates, in a massive map of meaning. Words with similar meanings end up closer together, while totally unrelated words are far apart. So instead of seeing just words or even raw numbers, the model is now working with vectors that capture context, relationships, and meaning. To us, it looks like string of number, but to the model, it's a refreshing dose of clarity. These numbers represent patterns it has learned from billions of examples. Once your text is tokenized and turned into these embeddings, it's ready to be fed into something called a neural network, which is essentially the model's brain and where all the real magic happens. This is where we look at the actual architecture of a large language model. A neural network looks something like this. You can think of it as a web of digital neurons, inspired by the ones in our brain. Each neuron is a tiny decision maker. It takes in bits of information, multiplies them by something called weights, which decide how important that information is, adds a bias, which is a little push to help it make better decisions, and then passes the result to the next layer. Multiply that process by billions of these neurons working together, and boom, that's the foundation of a large language model. If you want to keep learning more about machine learning and AI in a simple way, consider subscribing. If you like this video, please like and subscribe and leave a comment.